Okay, so a few more examples here, and these might go a little bit quicker because you don't have to copy them down, but you're more than welcome to if you want to. So on this example number 2, the first thing that I'm going to notice is that A out here is negative. So I know that my parabola is going down, meaning that my vertex is going to be a maximum. And then I'm going to go ahead and I'm going to shift over to this y-intercept. Now, if you'll notice here, I have an invisible plus 0 for my c. So that's always kind of a tricky one when your constant is 0, but that's okay. That just tells us that it goes through the point 0, 0. And again, once you get a point, please go ahead and graph it. It's much easier to graph as you go. Okay. I always like to jump to my vertex. So my vertex down here at the bottom is going to be x is equal to negative b over 2a. So when we use our values, we get negative 6 over 2 times, now watch this a is a negative 1 for this one. So when we go ahead and we simplify this guy, we get 6 over negative 2. Watch that negative. Now our axis of symmetry is x is equal to negative 3. Okay, so I know part of my vertex is negative 3 something. Now in order to figure out that y value, just take it and plug it in. So y is equal to negative. Be careful with your negatives here because you always want to make sure that when you square something, it turns positive. So there's a whole bunch of negatives here, but this actually turns into negative 9 because it's 9 times negative 1. And this is a positive 18. So my vertex on this guy ends up being positive 9. And again, once you get a value, so negative 3, positive 9, 2, 3, 4, 5, 6, 7, 8, 9, there we go. Please go ahead and graph it. Okay, now before I graph this guy, what I'm actually going to do is that I'm going to do my root form next. So my root form is 0 is equal to, and then we go ahead and we plug it in. So we have negative x squared minus 6x. Again, I'm going to factor this guy. Hopefully you see that there is a GCF, my favorite. Love a GCF. So 0 is equal to, I like to pull out the negative with the x plus 6. And you can still break this up. 0 is equal to negative x, meaning that 0 is equal to x, and 0 is equal to x plus 6, meaning that 6 is equal to x. So my two roots here are 0, 0, and 6, 0. Now, one of them also happens to be my y-intercept. That's totally fine. We can share. But then I'm also going to go ahead, negative 6, 0. Lost that negative there. That's okay. There's my other one. And that's why we go ahead and we check our work. So again, if you remember that kind of cheat with this, is that you get to take that factored form and plug it in with a y. So there's my root form. Okay, now I'm going to go ahead and I'm going to start graphing this. And it still works the same way with your relationships, but now that you're opening down, you have to remember that you're going down. So I'm going to go 1 to my right, 1 down, and I'm going to make a mark. 1 to my left, 1 down, make a mark. Now remember, always start from your vertex. So I'm starting from this purple point. I'm going to go 2 to my right. Now instead of going 4 up, I'm now going to go 4 down. So 1, 2, 3, 4. And then I'm going to go 2 to my left and go 4 down to match it on the other side. Now you can see here that our roots are already set up to be 3 over 9 down. And I'm going to show you that you can actually go 4 over. So I'm going to go 1, 2, 3, 4 to my right. And I'm going to go 16 down. So if I go to my x-axis, that's 9, 10, 11, 12, 13, 14, 15, 16. Hopefully you were counting with me. I know it's hard to see because you can only see what I write on here. But the cool thing is that you can also go over, and there you go. So now you can see that this is definitely taking the shape of a parabola. And we are going to draw nice curves all the way through with some arrows. Very last step that you need to do is your domain and range. So we have negative infinity is greater than or is less than or equal to x is less than or equal to infinity for that domain. Now for my range, I'm going to say that y has to be less than or equal to, and this is 9. And you're all done with that graphic organizer. Okay, let's go ahead and let's move on to this example 3 here. So for our example 3, some of the things we like to look at this. Y equals negative x squared plus 2x minus 2. That definitely is a negative out front, meaning that this needs to open down and your vertex is a maximum. Let's take a peek at that y-intercept. 0, negative 2. Once you get a point, graph it. Our vertex. So we know that x is equal to negative b over 2a. For us, this is going to be negative 2 over 2 times negative 1, meaning that we have negative 2 over negative 2. That's equal to 1. Our line of symmetry is x is equal to 1. My vertex is 1 something. Let's plug it in. So y is equal to negative 1 squared plus 2 times 1 minus 2. That gets us a negative 1 plus 2 minus 2. That gets us to negative 1. So here is my vertex. Oops, I didn't plug it in here. Okay, so then I'm going to go ahead and I am going to graph this parabola using my relationships that I know about parabolas. So for my vertex, go over 1, down 1, over 1, down 1. That happens to be the same. Now from my vertex, I'm going to go over 2, down 4, make a point, and again, over 2 to the left, down 4. Let's see if I can fit in this next one. Over 3, down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, down here on the very bottom. Down here on the very bottom. And then we're going to make some nice curves through this parabola. Okay, now if you'll notice, this guy is not touching the x-axis. So if I'm going to go ahead and I'm going to try for my root form, we're going to say 0 is equal to negative x squared plus 2x minus 2. Okay, no, I can't factor it, but what I'm going to do is I'm going to go ahead and I'm going to complete the square. I like completing the square. And we're going to see something pretty cool about this guy. First, I'm going to divide by negative 1. And that's to make sure everything's positive. So we have 0 is equal to x squared minus 2x plus 2. Then I'm going to add that c. So I have negative 2 is equal to x squared minus 2x. Now I need to add that special number. I'm going to do this in my head. Negative 2 divided by 2 is 1, negative 1 squared. I need to add 1 to both sides, so I'm going to say plus 1. Now, when I add 1 to both sides and factor, I get negative 1 is equal to, we have x minus 1 squared, and when you try to take the square root of this, no solution. No solution there. So this is not possible or not available for our root form. And that's because it doesn't cross the x-axis. So there's no solution for that guy. Let's quickly go ahead and fill in our domain and range though. I bet you already did it because you already know that y has to be less than or equal to -1 and your domain is all real numbers. Okay, I have one more example for you, and that is that we're working with something that might have roots that look a little funny. So first things first, let's figure out, oh, this is a positive out here, so it's opening up. It's a minimum. And our vertex is going to be x is equal to 4 over 2 times 1. If you'll notice here, I'm not writing everything out all the time. So as you get a little bit better at these, you can start to just show partial work on these, meaning that my vertex is going to be 2 comma some number. Let's go ahead, let's plug it in. So y is equal to 2 squared minus 4 times 2 minus 7. So we have y is equal to 4 minus 8 minus 7. So when we do all of those, we get x is equal to -11. Now this is going to be a little bit difficult to go ahead and graph on ours, but we can do it together. We totally got this. So sometimes on these guys, you have to kind of imagine that that point is down there at the bottom. That's okay. Okay, so we're going to go ahead from here. I forgot to fill in my y-intercept, so why don't you guys go ahead and do that. 0, -7, so 5, -7 here. Okay, so then, I also didn't fill in my axis of symmetry. You guys hopefully did, too. All right, and now from here, I like to go ahead and start graphing my parabola. So from this point down here, over 1, up 1, I know it's a little bit hard to see. Over 2, up 4, that matches that y-intercept that we had. Oops. Now over 3, up 9. 4, 5, 6, 7, 8, 9. Same thing on the other side. Okay, and now from here you also could 12, 13, 14, 15, 16, do over 4 up 16. Oops. Didn't go over 4 on that guy. So 9, 10, 11, 12, 13, 14, 15, 16. There we go. Okay, and we can really start to see this parabola forming. Now, what's so interesting about this parabola is that it does have a solution, but if you'll notice, these solutions with our root form are not going to be nice, pretty numbers. They're probably going to be irrational, meaning that you might have to solve in a different way. So I'm going to go ahead, I'm going to set equal to 0 is equal to x squared minus 4x minus 7. And again, I'm going to choose completing the square. So I'm going to add 7 to both sides. -4x, and then I need to add that special number, so -4 divided by 2 is -2, -2 squared is 4, so add 4 to both sides. I'm going to simplify and factor here, so this is 11 is equal to x minus 2 squared. Okay, and then if we take our square roots, we get the positive negative square root of 11 is equal to x minus 2, add 2, meaning that x is equal to 2 plus or minus the square root of 11. Now, your roots here, I'm going to have to go up here, are kind of interesting. Is that 2 minus the square root of 11, comma 0, and 2 plus the square root of 11, comma 0. Now, if you go ahead and you plug this into a calculator, I'm going to do it with you, is that you would get, so 2 square root 11, 2 minus the square root of 11 is about negative 1.31. And that goes through the point approximately negative 0.3. So yeah, that works. And then we're going to do 2 plus the square root of 11, which is 5.310, and that goes through just over 5. So those roots actually do work, but they're pretty tricky here. Now, I want you to watch something for our root-intercept form, is that y is equal to, and this gets a little bit tricky, is that you have x minus 2 minus square root 11, and you have to make sure that these are in parentheses, and then you have x plus 2 plus square root 11. Now, that's pretty challenging. You don't have to really worry about this so much. I'm just going to call this a challenge. But don't worry about it too much in terms of these root-intercept forms. Last part, let's fill in our domain and range. Negative infinity to infinity. And y has to be greater than or equal to 11. Oops, not 0. To 11. Okay, so hopefully those helped, and you can go ahead and you can complete your homework.